Still on the application of Surds, we now look at exact trigonometric values using Surds. Okay, so Surds can really help to get exact trig values. Um, so exact trigonometric values are special values of sine, cosine, and tangent that can be written exactly using fractions and surds instead of decimal approximations. So, I mean, with when I discovered this in high school, it was so sweet that I didn't have to always write things in for like using what is called the four-figure table, right? And you just get things only in decimals. So this um, was really useful, and knowing that there are some special angles we could work with using surds. So these values come from two special right angled triangles. So that's a 45, 45, 90-degree triangle. Then, of course, we also have a 30-degree, 60-degree, 90-degree triangle. By understanding these triangles, we can compute many trigonometric values without using a calculator. So first of all, we start with the 45-degree, 45-degree, 90-degree triangle, which we used the other time when we talked about right when we talked about isosceles right triangle, right? And that was where we saw that if the two adjacent sides have a value of 1, the hypotenuse will be square root of 2. If each of I mean if each of the adjacent sides has 1, so hypotenuse will be square root of 2. If each adjacent side has x, then the hypotenuse will be x root 2. For instance, if each adjacent side is 4 units each, the hypotenuse will be 4 root 2 units, like that. So in this case, we want to look at it in terms of trig ratios. So imagine the 45-degree, 45-degree, 90-degree triangle. Start with a square of side length 1. Okay, then draw the diagonal of the square. Now look at it this way. Okay, I'll read through and then I'll go to it. So this creates a right triangle with two angles of 45 degrees and one angle of 90 degrees. The sides are one leg is 1, other leg is 1. And then the hypotenuse, we already found it using Pythagoras theorem the other time. So the hypotenuse is found this way. Hypotenuse squared is 1 squared plus 1 squared, which is 1 plus 1, which is 2. So the hypotenuse is square root of 2. So the triangle sides are 1, 1, root 2. So it's a right angle or a right isosceles triangle or an isosceles right triangle. So let me go and demonstrate that on the worksheet. Imagine we have this square. So the square, of course, is 1 unit all around. So imagine now that you now draw this diagonal this way. So from this diagonal, if we take either of the triangles, right? So we know we have a right angle right here. So that makes this red line the hypotenuse. So this is the hypotenuse. Let me call it HYP. And then so for this now, if we now do this, so this is an adjacent side. This is another adjacent side. So let's call it edge 1, edge 2. So we know that from Pythagoras theorem, right? From Pythagoras theorem, from Pythagoras theorem, it is clear that hypotenuse squared is equal to adjacent side 1 squared plus adjacent side 2 squared, like that. So in this case now, each adjacent side is 1 unit. So it means that the hypotenuse squared is simply 1 squared plus another 1 squared. So we have the hypotenuse squared to be 1 plus 1. So the hypotenuse squared is 2, so that hypotenuse on its own now is square root of 2 when you take the square of both sides. Okay, so that's what we get from the hypotenuse from the Pythagoras theorem. So that of course you now see that this triangle has three sides, 1, 1, 2. So triangle has sides 1, 1, and root 2 rather. 1, 1, root 2, not 1, 1, 2, 1, 1, root 2. Okay, so of course, our ultimate goal is about the trig ratios. So we refresh our memories. interestingly, I have a playlist on trigonometry. You want to check it out. So let me just quickly show that to you. It's one of the earliest playlists I have in this in my on my channel. One of the earliest. Okay, so go for this now. So trigonometry. Where is it now? Yeah, right here. 10 videos on trig. So some of the things I'm doing now, I already treated here. So if you want to refer to it, you're very free. I think I did under special angles. That's what I did there. Where is it now? Special angles, yeah. So that's why I talked about all these 30 degree and all this 0, 30, 60, 45. Yeah. So I talked about all these kind of special angles right here. So I have all that. Then I established certain ideas like that. So we have yeah, so you want to check all of that out. I did proper justice to all these things. Yeah, so you see the special angles 0, 30, 45, 60, and 90 well taken care of. All right, so we recall the definitions of sine theta. We talk about so catois, right? So catois. So we have so, ka, and toa. Okay? So that's a sine opposite over hypotenuse. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, adjacent over hypotenuse. Tan is opposite over adjacent. Okay? So that's the idea there. And that's exactly what happens here. So sine theta is opposite to hypotenuse, cos theta is adjacent to hypotenuse, tan theta is opposite to adjacent. When we're talking about Pythagoras theorem the other time, I said we had two adjacent sides. But when it comes to trig, so we have to distinguish between the two. So imagine so normally you have this right angle triangle. So you have your right angle triangle this way. This is the hypotenuse without doubt because it is the side facing the bigger side. So, and normally I had called this adjacent one and adjacent two. But if we now have an angle to talk about, so if you have this angle theta now, it automatically makes the second adjacent what is called opposite because this is now the side opposite the angle, and then this now remains adjacent. Okay, so if I have the same triangle on this other side, okay, and then this is right, so but without doubt this remains the hypotenuse, right? And this is adjacent side one, adjacent side two. Okay, if my theta is now here, you know what happens? The adjacent side one automatically becomes the opposite, and this one just remains the adjacent. Okay, so that angle changes which adjacent side is opposite and which is adjacent. All right, so that's the concept there. And from what we have said, so any of this you look at, okay, maybe I should change this to alpha. So if alpha is in contention, so the opposite is here. So here I can say that based on SOHCAHTOA, I say sine theta is opposite over adjacent. Then, yeah, like that. Well, I mean, whatever. If it is theta still, it doesn't matter. So the rules apply always. So cos theta is adjacent over hypotenuse. And then tan theta is opposite over adjacent, like that. So with all of that in place, we then go on. Um, so let's begin to talk about the exact values now of 45 degrees. So you have sine 45 degrees to be 1 over root 2, sine 45, which is rationalized to root 2 over 2. Then cosine is 1 over root 2, which is also root 2 over 2. And then tan is tan 45 degrees, which is 1 over 1. So before I come to the summary, let me demonstrate that on the worksheet. So here you have, so again, as we know it, this is a an isosceles right angle triangle. So this is the hypotenuse. So if this is unit 1 and this is 1, we already found that this is root 2. So of course, this is 45 degrees, right? Because it is isosceles. So this is 45 degrees. So anyhow you look at it, so if you take sine 45 degrees, so if you take this 45, the opposite is 1, right? So that's opposite. The opposite automatically is this 1, and the adjacent is is also uh, opposite over hypotenuse, rather. So the opposite is 1. Uh, the opposite is 1. So if you take this 45, the opposite is 1. If you take this 45, the opposite is still 1. The hypotenuse remains unique. That's 1 over root 2. So you can rationalize this to 1 over root 2 times root 2 over root 2. So I already explained rationalization. That's root 2 all over 2. So all overall, we know that sine 45 degrees is equal to root 2 over 2, like this. So on the other hand, we have cosine of 45 degrees. So cosine of 45 degrees, if this is your focus, cosine is adjacent over hypotenuse. So if this is the focus, this is the opposite. So the adjacent is 1. So if this is your focus 45, the opposite is 1, the adjacent is also 1. So all over the hypotenuse, that is root 2. So of course, that will also automatically be root 2 over 2 because it's the same thing. And you then have cos 45 degrees to be equal to root 2 over 2. Now you may be wondering, why do we have sine 45 and cos 45 to be the same? There's a particular rule. There's a rule that um, there's a rule that if you take the sine of any angle, it will always be equal to cosine of 90 degrees minus the angle. Okay? It will also be always be equal to cosine of 90 degrees minus the angle. So that means that the same applies to cos. So cos theta is equal to sine 90 degrees minus that theta you have here. Okay? So what this means is that imagine if theta is 45 degrees. So it means sine 45 degrees will be equal to sine 90 minus 45, which is also 45 degrees. Same applies if you have cos 45 degrees, it's equal to sine 45 degrees also, based on this rule alone. And that is why sine 20 will be equal to cos 70, for instance. So, but 45 and 45, they are supplementary. They add up to 90 degrees. That's why we have that sine 45 and sine and cos 45 are exactly the same. Now, so let's move on to talk about tan 45 degrees, still based on that triangle. So for tan 45 degrees, tan is opposite over adjacent. So if you take this 45 degrees, the opposite is 1, the adjacent is 1. If you take this 45 degrees, the opposite is 1, the adjacent is 1. So that goes without saying. So we have 1 over 1, and that is 1. So that tells us that tan 45 degrees is equal to 1. Of course, there's another rule that tells us, there's a rule that sine theta all over cos theta is equal to tan theta. There's a rule like that. Does that hold in this case though? So it means if we try that for tan 45, does it work? So we have tan 45 degrees. So that should be the same thing as sine 45 degrees all over cos 45 degrees. Okay? What is sine 45 degrees? We already know that to be root 2 over 2, right? Sine 45 is root 2 over 2. Cos 45 is also root 2 over 2. That's basically 1, or if you want to be finicky, that's root 2 over 2 divided by root 2 over 2. Okay? So that means you have root 2 over 2 times 2 over root 2. If you invert that, this cancels, all this cancels. So the answer is simply 1, which is correct, right? It's what we have here. Okay? So so that way you don't need the calculator to remember what all of that would be. Okay? All right. So we have all of this now right here. Now we have the summary. You see, the exact values summary for 45 degrees. So sine 45 is root 2 over 2, cos 45 is root 2 over 2, also, and tan 45 is 1. So I showed you that sine 45 is cos 45 because the sine of an angle is equal to the cos of 90 minus that angle. So sine 45 is equal to cos 90 minus 45, which is still 45. That's why they are the same. And tan 45 is 1 because sine over cos is also 1. right? So apart from that, we go to the 30 degrees, 60 degrees, 90 degrees triangle. Okay. So the triangle that has angle 30, 60, 90. Well, no triangle actually has 30, 60 degrees, 90. But then if we can have a triangle that has 60, 60, 60 because an equilateral triangle has angle 60, 60, 60 all around. But then if we drop an altitude, drop a line, as I'm going to show you very soon, you'll see that. So start with an equilateral triangle. All sides are equal length. At length 2, all angles are 60 degrees. So draw a vertical line from the top vertex to the base. This splits the triangle into two right angle triangles. And once you have two right angle triangles, what happens? Half of the base becomes 1 each, and the hypotenuse remains 2. Now, you can find the height using Pythagoras as usual. And then that height gives you h squared equals 2 squared minus 1 squared. That's 4 minus 1, and that's 3. So h is root 3. And based on that now, you have the opposite to be 30 degrees. Opposite 30 degrees is 1. Adjacent 30 degrees is root 3. So hypotenuse is 2. You can then find sine, cosine of 30 degrees. So sine 30, 1 over 2 cos 30 root 3 over 2 tan 31 over root 3, which you can rationalize to root 3 over 3. And then you can also do the same thing for 60. So you have exact values for 60 degrees. Sine 60 is root 3 over 2, cos 60 is 1 over 2, and tan 60 is root 3. Well, I mean, I've talked too much about that. Let me go and demonstrate what I've just explained right now. Okay, so imagine you have an equilateral triangle. All the sides and angles are equal. So, and you know, the sum of angles of an interior, some of the angles inside a triangle is 60 degrees. So if all the angles are the same, right? So, let's say this is A, B, C, right? So if A plus B plus C is 180 degrees, all right? And A is equal to B is equal to C. That happens for equilateral, right? Okay. For an equilateral triangle. For an equilateral triangle. Then what do you say? You simply say that so the A plus then you can say that A plus A equals B equals C is simply equal to 180 degrees divided by 3, because each angle is equal and we have 3 of them. So it means that A equals B equals C is equal to 60 degrees. So in short, we are saying that this equilateral triangle, has an angle of 60 degrees each. 60, 60, 60, since all the sides are equal, 60 degrees each. So, and if we now take the length to be 2 units each, so let's say each side is 2 units each because it's equilateral, what happens now? Then you drop a perpendicular line here, draw a line, you know, which is perpendicular to this. So you have a 90 degrees here. That's how it ends up being a 30 degrees, 60 degrees, and 90 degrees triangle. So it started out as a 60 degrees triangle, but you can drop, because it is an equilateral triangle, you can drop an altitude which makes it into two equal halves. So from there now, we then have this kind of thing. Because this is like this now, so this angle now is 30 degrees. This is also 30 degrees. So two equal triangles like that. So we have this triangle coming out of that place. So we can bring it out now, and that will be, so we have this. So this is right angle. So this is 30 degrees, and this is 60 degrees. Then this is 2. But now that you have divided this into two equal halves, so this is equal to this half. So now this is 1, okay? And then we are left with this part. We don't know what this part is. What is this part? So we can call it h, right? That's the height. So that height, we need to find it, okay? So of course, from Pythagoras theorem, from Pythagoras theorem, from Pythagoras theorem, we know that h squared plus 1 squared, this adjacent side plus this adjacent side is equal to 2 squared, which is the hypotenuse. So that's h squared plus 1 equals 4. So that h squared is equal to 4 minus 1. and then h squared is equal to 3. Okay, so that means h is equal to square root of 3. So we have this hypotenuse now to be 3. So so the h is equal to root 3 as we have found right now. So we can then focus on that. Let's say for 30 degrees, right? We can then have this right angle triangle, and we're focusing on 30, right? So now we know this is 2, this is 1, and this is root 3. So this angle is now 30 because that's our focus. This is 62, but we don't care about 60 for now. Let's focus on 30 first. Okay, so for 30 degrees now, this is what we have. So we can then say we have so let's do, so for sine 30 degrees, 30 is sine is opposite to hypotenuse. So the opposite of 30 here is 1, and the hypotenuse is 2. That's why sine 30 degrees is half. That's 0.5. Okay, so we have that clearly. Then we have for cos 30 degrees. Cos 30 degrees is cos is adjacent over hypotenuse. So adjacent to 30 degrees is root 3, and the hypotenuse is 2. Straight to the point, we have that. And lastly, we also have that tan 30 degrees. Tan 30 degrees is opposite over adjacent. The opposite here is 1. All right. The adjacent is root 3. So we have 1 over root 3. And then we can rationalize. We have 1 over root 3 times root 3 all over root 3. So that is root 3 all over 3. So we can say that tan 30 degrees is equal to root 3 over 3, like that. Okay? So as you can see here, we already have this idea that, the other time I told you that tan 30 degrees, right, should be equal to sine 30 degrees all over cos 30 degrees. So that means, what is sine 30 degrees? That's 1 over 2. So 1 over 2 divided by root 3 over 2. Root 3 over 2. So that means we have 1 over 2 divided by root 3 over 2. That means we have 1 over 2 times 2 over root 3. So 2 cancels 2. So we then have 1 over root 3, which rationalized gives root 3 over 3. So that's just another way to consider tan, having done that the original way. So that's for 30 degrees, right? So let's go ahead and do for 60 degrees. So for the 60 degree side of things now, you have the same triangle, okay, where this is right, and this is now 60 degrees. This is 2, this is 1, and this is root 3. So we then go step by step again. So here we have sine 60 degrees. Sine 60 degrees is opposite. Opposite of sine is root 3. Okay. Uh, Sine is opposite to hypotenuse. So opposite is uh, root 3. Hypotenuse is 2. So that's what we have there. And then what else? We know that cos 60 degrees is adjacent to hypotenuse. Adjacent to 60 degrees now is 1, right? So that's 1. The hypotenuse is root 3, right? No, the hypotenuse is 2, sorry. The hypotenuse is 2. So that's 1 over 2. And then lastly, we have tan 60 degrees rather. For tan 60 degrees, so that's opposite of adjacent. So opposite to 60 is root 3. Adjacent is 1. So that's root 3 all over 1. Okay. Again, we can try out what I said the other time. We know that tan 60 degrees is equal to is equal to sine 60 degrees, sine 60 degrees all over cos 60 degrees. So that's root 3 over 2 divided by 1 over 2. That is root 3 over 2 divided by 1 over 2. That means we have root 3 over 2 times 2 over 1. So 2 cancels to, so that's root 3. So that works well with this, right? This is just root 3. So now, what did you notice? Have you discovered that sine, have you seen that sine 30 degrees is equal to cos 60 degrees? That's half each, right? So we see, so you can note that sine 30 degrees is equal to cos 60 degrees, and that is equal to 1 over 2. We have that. We also note that cos 30 degrees, okay? Cos 30 degrees is equal to sine 60 degrees, and that's root 3 over 2, right? So cos 30 degrees is equal to sine 60 degrees, which is equal to root 3 over 2. Now, why is that? It's the same rule I talked about the other time. I told you there's a rule that the sine of a particular angle is equal to the cosine of 90 degrees minus that angle. So if then the angle is 30 degrees, so sine 30 degrees will be cos of 60 because 90 minus 30 is 60 degrees. So of course the same rule applies if you have cos. So cos of theta is sine of 90 degrees minus theta. So that's what is happening right there. Okay, so yeah, that we have all of that. Um, yeah. So let's go back and summarize this whole idea. So you can see for 30 and 60, you don't have to punch a calculator to know what the exact values are. So complete table of exact values. Now you have for 30 degrees, sine is 1 over 2, cos is root 3 over 2, tan is root 3 over 3. For 45 degrees, sine is root 2 over 2, cos is root 3 over 2, and tan is 1. All right. Then for 60 degrees, you have root 3 over 2, 1 over 2, root 3 over 2 for sine, 1 over 2 for cos, and tan is root 3 over 1, or just root 3. So we have a memory pattern trick we can use here. So if you want to easily remember this, just look at this now. For sine, you have sine 30, 45, 60, that's root 1 over 2, root 2 over 2, root 3 over 2, easily. So just, you have 2 all the way under. So you just have root 1, root 2, root 3. Then in reverse order now, so just reverse this thing and you have for cos 30, cos 45, cos 60, that's root 3 over 2, root 2 over 2, and root 1 over 2, like that. Okay? So we have all of that. Of course, tan isn't here now, but tan, you can easily get tan by just saying roots, by just dividing. So for tan 30, you just say root 1 over 2 divided by root 3 over 2. That's 1 over 2 divided by root 3 over 2, and you get what you need to get. Okay, so we can take examples. So find sine 60 degrees plus cos 30. Sine 60 we know is root 3 over 2. Cos 30 is root 3 over 2 because they are the same, right? Sine 60 is equal to cos 90 minus 60, that's cos 30. So we just have 3 over 4 for that easily. Then for number 2, we have tan 30 degrees plus tan 45. Tan 30 is root 3 over 2, root 3 over 3, and tan 45 is 1. So we just have 1 plus root 3 over 3. You can simplify that further if you like. So that's simply root 3 plus 1 over 3 generally, or 1 plus root 3 all over 3 in all. So you want to evaluate sine 60 over cos 60. Sine 60 is root 3 over 2. Cos 60 is 1 over 2. So multiply by the reciprocal, you have root 3 over 2 times 2 over 1. You just have root 3 straight there. Okay, I think I even demonstrated this just now to show sine over cos is tan, right? That's what I did right here. So sine 60 over cos 60, that ends up with root 3 over 2, like that. Then we have, so I mean, that ends up giving us tan 60, just like I showed before. Then for example 4 now, 2 sine 30 plus cos 60. So that's 2 into half plus 1 over 2. That's 1 plus 1 over 2. That's 3 over 2 easily. So we have practice problems here. Let me see which ones I need to take. Um, okay, I'll take 5 and 10. And then I'll take another 2 there if possible. So 5 tan 60 minus tan 30. Okay, tan 60 minus tan 30. So tan 60, tan 60 degrees minus tan 30. I hope that's what it is. Question 5, right? Tan 60 minus tan 30. Yeah, that works. Tan 60 minus tan 30. So I'll just refresh. So if I didn't have this, I would have done it afresh. Tan 30 is root 3 over 3. Tan 30 is no, tan 60, right? tan 60 minus tan 30. Okay, so what is tan 60 now? Tan 60 is root 3. So this is equal to root 3. And tan 30 is root 3 over 3, right? Tan 60 is root 3. Tan 30 is root 3 over 3, yeah? So we can simplify this now. So this is like LCM 3. So that's 1 in 3, 3. That's 3 root 3. Okay, 1 in 3, that's 3 root 3 minus 3 in 3 is 1. 1 times root 3 is root 3. So 3 root 3 minus root 3 over 3, that's 2 root 3 all over 3. And that is what we have there for tan 60 degrees minus tan 30. Okay, so question 10 now. For question 10, we have sine 30 over cos 45. Sine 30 over cos 45. So sine 30 degrees all over cos 45 degrees. I hope that's correct. Sine 30 over cos 45, okay? So we know sine 30 degrees should be 1 over 2. Yeah, sine 30 is 1 over 2 here. Then cos 45. Okay, cos 45, we did that a long time ago. Cos 45 is cos 45 is root 2 over 2. Okay? 1 over 2 divided by root 2 over 2. So this is 1 over 2 all over root 2 over 2. So that's simply 1 over 2 divided by root 2 over 2. So that means we have 1 over 2 times 2 over root 2. 2 over root 2. So this cancels out. And then this is 1 over root 2. And we can rationalize. That's 1 over root 2 times root 2 all over 2. All over root 2 rather. So that is root 2 over 2 overall. Okay. So that's like so it's looking like sine 30 over cos 45 is evaluating to um cos 45 again, or even tan 45. So that's root 2 over 2. I hope that's fine though. I think it is. Yeah, 1 over root 2, which is root 2 over 2. Yeah, so that's question 10. I think I'll take another 2 here if necessary. Okay. So I've done 20, that kind of 20 thing before. So let me go for, mm, is this important? Okay, let me do sine squared 45. Okay, sine squared 45. Sine squared 45. Sine squared 45 degrees simply means sine 45 degrees all squared. And we know sine 45 degrees to be root 2 over 2. Um, just to be sure, sine 45 is root 2 over 2. Yeah, so that sine 45 is root 2 over 2, or 1 over root 2 if you like. So sine 45 is root 2 over 2 all squared. That's what that means. So it means if you square that, that's root 2 all squared all over 2 all squared. So root 2 squared is 2. 2 squared is 4. So sine 45 squared is actually 1 over 2, like that. So then I'll go for the last question here, and that is let me take question 19. Of course, I mean, sine 60 is root 3 over 2, and cos 30 is the same thing, right? So sine 60 is root 3 over 2, cos 30 is the same. So that will be 9 over 4, 3 over 4. So I'll take sine 60 plus cos 60 over sine 30. Sine 60 plus cos 60 sine 30. So sine 60 plus cos 60 degrees over sine 30 degrees. So that is sine 60 again. Let me try to be sure. Sine 60 So what I do most times is, even if I don't remember this, I'll just draw the triangles and extract those values again. So sine 60 is root 3 over 2. Okay, sine 60 is root 3 over 2. Cos 60 is 1 over 2, clearly, because sine 30 is 1 over 2, so cos 60. So sine 30 again is 1 over 2. So we can tidy things up. So at the top, now the LCM is 2. So 2 here, of course, all over 1 over 2 again. So 2 into 1. So we have root 3 plus 1, like this. So that means, so we can then have root 3 plus 1 over 2 divided by 1 over 2. So we then have root 3 plus 1 over 2 times 2 over 1. So 2 cancels 2, and then this is equal to root 3 plus 1, or if you like, 1 plus root 3. And that is exactly the answer we get for that. Okay, so with this, we come to the end of this interesting video, of this interesting lesson on exact trigonometric values using surds. So don't forget to try your hands on the practice questions. So maybe I can zoom them in fives. This is 1 to 5. Okay, this is 6 onwards. So you have 6 to, say, 12. Okay, 6 to 11. Okay, so try your hand on this. Then you have 12 to 18. 12 to 18, and the rest of them. So just try your hands on this and see how well it goes. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed to this channel, I must thank you very much for doing that. If you haven't, question is, what exactly are you waiting for? Go ahead, subscribe, and hit the notification bell so you can always get alerted each time a new video is released. You can also become a member of this channel by clicking on join. That gives you special privileges like getting to see some videos first, or being the only one to see some videos as a member of this channel. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.